Hello, my name is Irene Wright, and this is GIS 2011 Lab 2 with Dr. Shannon. In this lab, we were required to make two separate maps within GIS that represented employment rates for both men and women in two different fields. To begin, we obtained the employment data of men in manufacturing and women in educational services from U.S. Census data that was consolidated and represented in NHGIS, which is the National Historical Geographic Information System. And this took this data and put it in a non-spatial consolidation that was represented as a CSV spreadsheet. And we can see that this data was cited in the bottom center of the men's graph and in the bottom left of the women's graph right here. Once we had our data attained from NHGIS, we had to decide whether to report it as a rate or a raw count. We chose to represent the data as a rate in order to better reflect the percentage of men and women in their respective professions separate from population. So if we had showed a raw count, obviously more populated states would seem to have a lot more men in manufacturing and women in education compared to less populated states. For example, if you had looked at a place like California versus Michigan, if you went by straight population over in California, this probably would have been a lot more filled in and less so in some place like Michigan. But when it's represented as a percentage of the population, it's a lot more accurate. In order to do this, we took the data that was given to us by the census and placed it into the CSV spreadsheet. And then we took that information and put it into QGIS. And once we were in the QGIS, we were able to use the expression fields and symbology tools by opening the properties window and then adding the metadata given in the spreadsheet to the expression box variable table. So that was written as total men over the total men in manufacturing divided by the total male population times 100. So you can see that in the center bottom of the screen. This is just an example of how we wrote that metadata into the symbology table. And here, this value would be the total men in manufacturing divided by the total number of men in the population. And this would give you a number below 0, so we times it by 100 to get a rate, which is given as a percentage in this case. And that's what you see in the data table and in the legend as percent men in manufacturing, and then over in women is again women percent in educational services. And that gives you the rate that we used. Once we had all the rates placed on the map, we were able to see trends across the professions and between regions. So if we start with men in manufacturing, we can see the highest concentrations of men that were working in manufacturing from 2013 to 2017 were centered around the Great Lakes, some into the south and a little bit up into the northeast. This is represented by orange counties, which had the highest percentage for the data that we had. And these are historically industrial areas, so it does make sense that these trends would continue to stay there. Midwest is predominantly agricultural, so you see a lot fewer of the manufacturing jobs to the west of Texas. And then if we look over into women, it's a different, interesting look because it is relatively evenly spread across the country. But to point out some places, if you look over in California and up the West Coast, these are predominantly liberal areas, and they have a lot fewer women in their educational services compared to a conservative center of the country in which it's almost a majority women in educational services. And I think this is an interesting look at how different views reflect the professions that are available to women. And these trends were able to be highlighted by the classification and color scheme of the maps. So we made choropleth maps, which include polygons with a color scheme to represent some kind of quantitative data. In our case, the polygons were our county shapes, since the census data was given by county, and the quantitative data was the count data values for employment. I then chose a sequential color scheme, which works with value to show variance between counties. The women used a red value map with the lighter shades representing lower rates. And then for the men, I used a red-orange value map with lighter shades representing the higher concentrations. While other colors were present in the legend, for men there weren't any data for that range, and therefore they weren't represented. And these help show the trends because they mark a clear visual difference between highs and lows. And since the quantitative data is being represented on a gradient, a hue-based color scheme would not be appropriate in this situation. So that's my maps for Lab 2.